Okay, so let's see what this looks like when I actually try to put all of this together and work some problems. So I know a big thing was I don't know the order in which to work things, Miss Love. So here's what I'm telling you the order is. You are going to work PMA first, then you are going to work your quotient rule and your zero exponent rule. And then we're going to talk about what happens in my final answer if I get no negative exponents. So now, remember, our goal here is to simplify this down. Right now, I have two bases that are numbers. I have 4 and 3. I have two bases that are A's. And then I have two bases that are B's. My goal when I simplify this is to get my two numbers that are my bases down to a single number. The two A's, write them as a single base of A with a single exponent, and then take my two bases of B and write them as one single base of B with one single exponent number. Okay, so I don't want to see two A's, I don't want to see two B's, I only want to see one A, one B, both with their own exponent at the very end. Okay, so let's take a look at this. So we're going to start at power to a power. I need to be able to recognize when I have that rule so I know when to multiply. I am not seeing any parentheses and I'm not seeing an exponent outside the parentheses, so I'm going to move on to the next operation. Multiplication. We have multiplication going on right here with this dot. So I'm going to now start working multiplication. Okay, so now I'm going to take my first base, which is A. Remember, we're going to come back to those integer bases in just a second. So A. And I always like to circle my bases, my exponents, and connect them so that I know which two numbers I'm working together. Okay, so if we're multiplying, is that the operation we're using on our exponents? No, we are going to be using A, stands for addition. So what do I get when I add 3 plus a negative 4, or 3 minus 4? You are going to get a negative 1. Okay, next base, B. All right, so let's see what my two bases are. I've got an exponent of 2, and now I've got an exponent of negative 3. All right, so that's going to give me an exponent of negative 1. Okay, now I'm going to deal with my bases that are numbers. Okay, so if I imagined that the A and the B were not there, both A's and both B's were gone, I would just be left with a plain multiplication problem of 4 times 3. And what does 4 times 3 create? It creates a 12. Okay, so now I've gotten down to where I'm at a single base of A with a single exponent, a single base of B with a single exponent, and now I have multiplied my bases that are numbers and gotten 12. So now I'm down here. I got to check for the quotient rule. And you'll notice the quotient rule when you see a big fraction bar. I didn't have a fraction bar, so I'm not going to apply the quotient rule. And then I need to check. None of my exponents are 0, so I will not apply that rule. But I have to make sure that my final answer is not written with negative exponents. Okay, so let's look back here for just a second. We said that if we are having a positive exponent, it is telling us how many times to multiply. Multiplication. So if my exponent is now negative, which is the opposite of being positive, what operation do you think we're going to use to apply to the base? Well, what operation is the opposite or the inverse of multiplication? It would be division. So here's what we're going to do. We are now going to show any base that has a negative exponent, we are now going to show it with division. And what symbol do we use to show division? We show division now with our fraction bar. So now I have to decide, is the A going to be in the numerator or the denominator of division? So you've got to think back to your solving equation skills. The number you divided by to get your final answer for X or Y, was that in the top or the bottom of the fraction? And hopefully you say the denominator. So this A is actually going to move down and become part of our denominator. And when we do that, that 1 is going to go from a negative 1 to a positive 1. Okay, do I have any other negative exponents? I do. The base of B also has a negative exponent. So we're going to apply the same rule to this to make our exponents all be positive. So again, this shows that I'm dividing by b. So the b will now join the a down in the denominator. And so now I am dividing by a and by b, which is what I want. And now I have to take care of this 12 because I can't just leave it off. It's part of my final answer, so I need to make sure it gets written down with my final answer. And since its exponent is actually an invisible one, it's a positive, so it's going to stay and become part of the numerator. So this would be my final answer that I would be looking for on a quiz or a test. I would have 12 all divided by the product of a and b. Again, we are not trying to find the answers for a and b. We want to take it from where we see multiple of the same bases and we kind of sort of combine them where I end up with one base of each different variable. And I end up with one number base, okay? All right, let's look at another one because the more you practice, the better you're going to get at this. So the next example, I have 6 times m to the power of 3 times n to the power of 3, all multiplied by 8 times m to the power of 2, n to the power of 2. So again, we're going to start off by identifying all of our bases. Those include the numbers. So I've got a 6 and an 8. I see an m here, and then I also have a base of n here and here. Okay, so now we're going to start back at the beginning. We're going to see, do we have power to a power rule? Well, I don't see any parentheses, and I don't see an exponent outside the parentheses, so we are going to start off with m, multiplication. I see that I have multiplication right here, and I always like to emphasize my multiplication so that I don't overlook it, especially if they're using that little tiny dot. It can be easy to overlook. All right, first thing, we're going to write our m base, and I know that I'm using the multiply law, which means I can't use multiplication on my exponents. I've got to use something else, so I'm going to follow my arrows. After m comes a, which tells me I need to add, so I'm going to get an exponent of 5. I have now taken these two bases of m's and written it as a single base of m with a single exponent of 5. And now I'm going to do the same thing for my base of n. I have an exponent of 3 here and an exponent of 3 here, and since I'm multiplying, I can't multiply my exponent, so I have to follow the arrows to a. A stands for addition, so that would be 3 plus 3 is 6. All right, so now we're going to play pretend. What if those m's and n's were gone? What would I do with the 6 and the 8? Well, I'd be left with a multiplication problem, and I know that 6 times 8 is 48. So I would get 48 times m to the 5th power times n to the 6th power. Okay, we're going to check the rest of our rules to see if we need to clean up anything before we get our final answer. Okay, again, I don't see a fraction bar, so no quotient rule will be used. I do not have a 0 exponent, so I don't have to worry about taking care of that rule either. And then none of my exponents are negative, so this would be my final answer that I would either write down or that I would look for in multiple choice quiz or tests. All right,